Hello guys, welcome back. Previously we have seen about querying from ICAR-CRIDA website using large language model. So far we have covered project scope and business understanding, project execution plan. Today we are going deeper into demo and future updates. Let me brief out the project statement. It is to design and develop a language model based system to facilitate querying of reports or documents from ICR-CRIDA website. So, what is ICR-CRIDA? It is a premier institute in India dedicated to addressing the challenges of dryland agriculture through research, technology development, and capacity building. The institute focuses on developing sustainable agricultural practices and improving productivity in arid and semi-arid regions of the country. Every problem arises from a real life situation. This is no different. This is a potential need of agricultural officers. During meetings with higher officials, they need quick responses, and going through bulky annual reports is time consuming and exhausting. This ICR-CRIDA based LLM lightens their work by offering a seamless and efficient way to access important reports and documents. Welcome to today's presentation, where we'll showcase an innovative solution addressing the challenges of efficient document retrieval and multilingual querying in context of agricultural research. Our project harnesses the power of advanced language model and modern web technologies to create a seamless user experience. In this demonstration, we'll walk you through how our system utilizes fast API, sentence transformers, and BART from Hugging Face Transformers library to enhance document search and retrieval processes. We'll highlight our approach to integrating these technologies, allowing users to query reports and documents from the ICR-CRIDA website with precision and ease. Let me first give a quick view of the architecture diagram of this application. So far, we have three kinds of users. One is the unregistered user or the guest user. Other is the registered user. And here comes our admin. The only difference so far between the unregistered and registered user is the history. The history of registered users chat is saved in MongoDB. So what happens here? As we can see, first we are going to web scrap from the ICR-CRIDA website. We are going to take the annual reports using Beautiful Soup, which is a HTML parser, and request for getting the HTML data. And right now we are going to extract the data using fits. Later we are going to pre-process the data using remodule, like removing all the extra lines or unnecessary symbols. And next we are going through the chunking process. We are using NLTK, which is a natural language toolkit. Here chunking, first we did it based on the sentence, which is nothing but sentence chunking. Later, due to the insufficiency or to be precise, due to the less amount of tokens the generating model takes as input, we have got to reduce the chunk sizes. For that, we have used word chunking. Now, after the chunking process, we are going to do tokenization and later vectorization. First, tokenization is nothing but changing the words into numbers, and later comes the vectorization. Here we are going to change those words into vectors. These vectors show the relations between words. And right now we are saving these vectors into a vector DB. Here we chose chroma DB for storing the vectors. This process is nothing but embedding creation or nothing but vector creation. Now, when comes to the real aspect of the RAG model, nothing but generating answers. First, we are going through cosine similarity. The prompt or the question given to the model is also converted into a vector using the same previous embedding model. After conversion to the vector, we are going to find the most nearest or relevant vectors from the vector DB using cosine similarity. Here we used cosine similarity. Apart from that, we can use Euclidean distance or KNN as well. Later, we are going to give these relevant documents or data to the LLM model, which will generate the answer that is shown to the user. Either it can be the registered one or the guest user. These messages are stored into MongoDB for registered user. As for the guest user, they are just going to view the answers for the questions they have given. Now let's look into the application part. This is the landing page, which is nothing but the entry point of our users. So far as I've talked, there are two types of users in this application, which is the guest users and the registered users. Users can easily navigate to other parts of the application from here. So for the unregistered or the guest users, they can directly go to get started and open the chat interface. This chat interface is nothing but the heart of our application. Here the users can interact directly with our system. The guest users are directed to this page where their history is not stored. If you want to store your history, you should log in. Let's try giving a query to this LLM. I have randomly taken a query like what are the achievements of ICAR-CRIDA in 2022? When I send this question or prompt, like when I click enter, the system processes the query, communicates with the language model, retrieves the most relevant documents, and generates the desired answer. As you can see, you have got the desired answer over here. Now, if the users are like new users, then they can register for themselves first if they wanna save their history, like by using sign up. This is a simple and straightforward process where you are going to give an email, you are going to give a password, and for further validation we are using a confirm password. Now, if I give an email address for this with a password randomly, now I sign in. When I sign up, I'm redirected to the chat page where my history is being stored. So far, the back end of the history is completed, but as for the front end, it's a bit lagging. And here we have used BART model. The model I am using is BART right now, as you can see here. But for the same thing, we have also implemented it using GPT-2 model. We will further implement it using T5 model as well. So, as the same scenario with the unregistered user or the guest user, Here you are going to give a query like what are the achievements of ICAR-CRIDA in 2022. When I hit enter, the same process takes place again. The system processes the query, communicates with the language model, retrieves the most relevant documents, and generates the desired answer. The answer is going to be shown here. So, as you have seen, you have got the answer. And apart from the sign in, there is another option as login. If you are already a user, then you can directly log in from here. Like I've created the account using this login, so this credential. So I'm going to use the same for login to show you that it works. Certain authentication is working over here. Like I can go to MongoDB to show you that. Okay, here I'm signing into it. So behind the scenes, our backend is built with Node.js and Express, managing user authentication, handling search queries, and connecting to our MongoDB database. As you can see, this is the MongoDB database which we are using, MongoDB Atlas. And as you can see, the backend for the conversations, as I have mentioned before, they are being stored like this. And the messages regarding to that chat conversation, the logic is implemented as this. The user ID, the user ID is used to save a conversation. The conversations are directly mapped to user IDs, and the messages are mapped to the conversations to make it simpler so that we have an interface for conversation which we are going to store in this sidebar. So going next, as you have seen the uh, walkthrough of the application, I'm going to explain it deeper from the backend, from the code perspective. So for the front end, we have used React. So why did we use React? React's component-based architecture and virtual DOM make it ideal for building dynamic and responsive web applications. It enhances developer productivity and ensures a smooth user experience. Though I've used React for this, I'm using Tailwind.css rather than Bootstrap.css because allows for rapid UI development with a consistent design system. Its utility classes enable quick and flexible styling directly in the JSX, reducing the need for custom CSS and improving development speed. As for the backend technologies, as I've mentioned before, I've used Node.js, Express.js. Node provides a scalable and efficient runtime environment for server-side applications, whereas Express.js is a minimal and flexible Node.js web application framework, which is ideal for building RESTful APIs using quickly. As for the database, I've used Atlas, MongoDB Atlas. That is because of its flexible schema and scalability, which make it a good choice for handling varied and growing data requirements. So this is the uh, main directory, which is LLM server, from where the querying answers, the RAG model is situated. So when you look at this landing page, the entry point, it is a very moderate, very simple and neat React state uh, React state page. So here I've included navigation links so that I can be navigated to other parts of the website, which is in the navigation landing navbar that is directly shown here in the landing page. As for the chat page, which is the heart, uh, we are we are going to manage the search query and response. Here the handle search function, this it is a handle send function. And when coming to this, yes, first we are going to state the messages, which is nothing but what it is showing us, who are you and I am AI. I'm making it default. Later I'm going to see if the user is authenticated or not. If he is authenticated, his history is being stored. If not, his history will not be stored. I'm going to fetch messages. This fetching is done from the user, MongoDB. Routes I'm giving it in the backend. Uh, Whereas this handle send is going to get me the query as well as the answer messages. This is going to send these queries to the backend. So far, I've used conditional rendering to check for the login and guest user. So going for the login and sign up is direct and simple, straightforward code where I'm cre creating a controller in the backend where I'm going to store the user data. I'm using bcrypt to hash my data for better authentication and for security. And I'm logging in user using his ID password. I'm going to find him using email. Then I'm going to match his password. If his password is not matching, I'm not gonna allow him. As for the user schema for the MongoDB to have a consistent data, here router, I'm using the middleware router to uh, connect the backend and frontend. We are using Express for this. As for the MongoDB connection, it is over here. We are using Atlas for MongoDB, and all that jots down to this index.js. When coming to my main part of the application, this main.py, here I'm using Fast API. Fast API is modern, fast, and easy to use. It supports asynchronous programming and automatic generation of OpenAI documentation. Now, here I'm using cores. Why is this so? Because the front end and the back end are running on different ports. So for the backend to access uh, the request from the front end, I'm going to add this course settings. And next comes the Pydantic. This ensures that incoming request data is valid and adheres to the expected format. Next comes the sentence transformers. This is efficient for transforming text into embeddings that can be used for similarity comparison. Next is the SQLite, lightweight and easy to set up for small and medium applications. This serves as a database to store embeddings and document chunks. Now, I'm importing transformers. Uh, for the Hugging Face Transformers library is state of the art for NLP tasks and supports a wide range of pre-trained models. We utilized BART over here, a BART model to generate responses based on the required context. And Torch is flexible and widely used framework for deep learning, used for handling computations on the GPU if available. So far in my system, GPU is not available. So what am I doing? I'm initializing the fast API. Later, these sentence transformer and BART models are loaded over here, as you can see. Next, the connection is made to the DB, which is final DB, where all the data comes and stores into. I guess the VS Code is not supporting it. Uh, and next comes the retrieve embeddings from DB. This function retrieves text chunks and their corresponding embeddings from SQLite database. Now going further, the query processing is done using query with BART model with three chunks function. This encoding the query into the embeddings using sentence transformer. Then later we are calculating the cosine similarity over here. And then we'll take the top three chunks from here. Closest chunks are taken over here. And then we are going to tokenize this input text and generate a response using BART model. The endpoint for all this is going to be the slash query over here. Uh, this accepts a post request with a query, retrieves the embeddings, finds the most relevant chunks, and generates a response using the BART model. Next comes the save model.py. In this save model.py, as you can see, there is OS sentence transformers, as I have mentioned before, sentence transformers and transformers are there. The model, loading model, defining their paths, and creating directories to save them. And next, saving the models. All this part is done in this save model. So, as for the problem statement, we have seen what all has been uh, gone through in the demo. Now we have seen the search functionality, document retrieval, and as for the language options, we are going to update it in the near future. So the potential updates are real-time updates like automatic updates of new documents and reports. We can add this using in the admin portal, admin front end page, like admin website where the admin just clicks on a button. Using web scraping, we are going to get the data. Like if any new documents are there, these documents will be passed to the function, passed to the RAG model for the embeddings. Then he'll store it into vector DB. After that, the document can be used for the further querying. And collaborating tools like we have used document connection collections in Chroma DB, but so far that document collections is based on uh, uh, is like giving inaccurate answers for some models, which are giving quite accurate answers when they are not connected to the backend and stuff. Now we can add multilingual support by adding Hindi option or even more languages. So far that's all. Thank you for your time and patience. This is presented by Kotam Rakshita.